Okay, so ladies and gentlemen, just a quick reminder for those of you who are not here today, we are balancing triangles on Wednesday if you'd like to get the 5 extra test points. And we are test corrections. Make sure you get them into me by Wednesday also. Okay. All right, my people, here we go. So example 1 and 2, your job is to put these things in order from least to greatest. We also need to see who's going to pull sticks today. So who pulled sticks last time? Austin. So you will pull a stick to see who pulls sticks. Now, we do have the spreadsheet in there. So Sam, we probably should check that with Sam's spreadsheet. Okay. All right, Austin, pull me a stick. Who's pulling sticks today?
Nicole.
Now, Nicole, have you pulled sticks during this round?
Not this round.
I want to pull sticks. Okay, all right. We will add. Sam, can you double check that Nicole in your spreadsheet has not pulled sticks?
Nicole has not pulled sticks.
Okay, can you add her to your spreadsheet, please?
Yes, sir.
Okay, thank you, Sam. All right, so this is example 1 and example 2. We're just going to randomly call on kids, and these kids are going to tell us how to put these in order from least to greatest. Okay? Using the, I believe this will be the, is this the converse of the isosceles triangle theorem? I think it is, right? Okay. Actually, it's not the isosceles triangle theorem. I apologize. It's the triangle inequality theorems, right? Yep, my bad. Inequalities and triangles. What's that? Okay, so if you weren't here for this is why Mr. Roden is doing this. If you were here for this and you didn't understand it, this is why Mr. Roden is doing this. Okay, so let's pull a stick here, Nicole, right off the bat, and we'll get started. Okay, so Sam. Now, all this side conversation, let's stop. Okay, so Will, have you written these problems down in your notebook yet? Okay, can you do that, please? I need everyone to do this, okay? If you're on a computer, you're on a computer because you're typing in the notes, nothing else, okay? Now, first of all, we need to remember this, guys. The longest side, if you need to write this down, great. If not, if you have it in your note, great. The longest side lies opposite the greatest angle. That's the key here. You guys understand that? Okay. So when we're looking so for each, write a side in order from least to greatest. Okay. And we're going to use an inequality for this. Okay. All right. So Sam, what angle is the smallest?
The smallest angle is angle B.
Angle B. What side lies opposite angle B?
Side AC.
So AC is the smallest side in this triangle. Does everyone understand that? Okay. Now I will say this, ladies and gentlemen. Do we agree that AC lies opposite B? Okay. Sam, what would go next after that? I said an inequality, but I think I'm just going to put commas because inequalities would mean I'm actually going to put the actual sides with the segment over the top. Okay, go ahead.
It's BC because angle A is 65. And that is
Okay.
not the biggest one.
Okay, so it's BC. You guys agree with that? Okay. And then Sam, what will come last?
BA.
BA. Okay. Y'all understand that? Okay, very simple concept. Okay, but it's a very huge concept that the smallest angles lies opposite the smallest side and vice versa. Okay, nice job. So number 2, example number 2. Nicole, can you pull me a stick on that one, please? Who is it? Kaylee. Okay, so Kaylee, before we can do example 2, we need to figure some information out here, right, Kaylee?
Yeah.
So what do we need to figure out before we can do example 2? Angle D. So how would we figure out angle D?
You would add angle E and F together
to get 112 and then subtract 112 from 180,
Which gives you what?
which gives us 65.
Do you guys agree with that?
No.
68, sorry.
Do you guys agree with 68?
Come on.
Yes or no? Do you guys agree with 68? Okay, now, here's the deal. That's called what, if we want to officially say what she used the triangle angle sum theorem, right? There's always 180 degrees in every triangle on a plane, okay? And we should always remember we're talking about flat surfaces. Triangles, if you put a triangle on like a ball, if you draw a triangle on like the globe, triangles actually have more than 180 degrees in them. But we're talking about flat surfaces, planes, okay? All right. So with that being said, Kaylee, let's go ahead and put these in order from least to greatest.
From least to greatest, so then it would be ED.
Okay, you guys agree with that? Okay.
And then EF.
EF.
The same thing.
Yep, same thing. Yep.
And then FD.
And then what's last?
FD.
FD. Okay, do you guys agree with that? So
Thank you, Sam.
these are all really good, easy test questions. So all y'all who get stressed on tests, here's an easy type of test question. It would be put the usually I'll probably leave an angle off, and I'll say put the sides in order from least to greatest, or I might say put the angles in order from least to greatest if I give you the sides. Are there any questions there? Okay. Now, this next one is this is a great problem, okay? So I want you guys to go ahead and we're gonna do this one together here, okay? So what I want you guys to do is I want you to copy down this problem right here. It's a really, really good problem, okay? So given the information in the diagram, prove. Now it's not just saying we actually have to prove it, okay? We're going to prove that PQ is less than PS. Now it might be obvious, but I want to show you that it's not as obvious as you think. Or maybe it is obvious. I don't know. We'll see. Okay. So when we're doing inequalities in triangles, you can only compare one triangle at a time. You guys understand what I'm saying? We have two triangles here, guys. We have we'll call this triangle 1. Or no, let's name them, Mr. Roden. We have two triangles. We have triangle QPR, and we have triangle PRS. Okay, and I'm just going to call one triangle 1 and one triangle 2 just for the sake of it. So you cannot use the inequality to compare one side or angle in another triangle, okay? You can't just explicitly say, well, and here would be the reasoning here. Well, you would say that in a triangle, the greatest side lies opposite the greatest angle, right? In a triangle. But you're talking about one triangle here. So you cannot use that in another triangle. So what we're trying to do is we're trying to compare PQ. Okay, well, where's PQ, Mr. Roden? PQ is this side right here in triangle 1. See that? To PS. Well, where's PS, Mr. Roden? That's this side right here in triangle 2. And we need to show that actually that PQ is less than PS. But the problem is they're in two different triangles. You guys see what I'm saying? So how do we compare sides of triangles in two different triangles? Well, we've got this very nice reflexive side right here. And this is going to be the key, this reflexive side. You guys understand that? Okay. So what we're going to do is we're going to make an inequality. First of all, let's figure out what this missing angle here is in triangle 2. So your job right now, and I'll pull a stick on this in a second, your job is to find the missing, I need to know what angle PRS is equal to, because I think that's going to be important. Okay, and even though this is a very simple problem, we can make this a little more challenging. So I want you guys to understand the concept that we're about ready to do here, okay? All right. So Nicole, can you pull me a stick? And this student is going to tell me what that angle is. Who is it, Nicole? Dakota, what's that angle right there? Okay. Okay. Take your time. Take your time.
To find the angle, you would add 37.63, which is equal to 100, and then you would subtract that from 180.
So what is it?
It would give you 80.
80. Do you guys all agree that's 80? Okay, good job, Dakota. So that's 80. All right. So now what we're going to do, guys, is we're going to make an inequality in triangle 1. Okay, so just look at triangle 1, which is triangle QPR. Nicole, can you pull me a stick? And this student's going to we're going to put the sides in order from least to greatest. Okay, go ahead, Nicole. Will, on triangle 1, what is the shortest side, Will?
Is it QR?
Okay, so look at triangle 1. Will, the shortest side lies opposite the smallest angle. What is?
Okay, it's QP.
It's QP. Very good. So we know it's QP. Okay, that's less. That's the smallest one. Will, what would be the next angle?
Is it PR?
Is it?
I don't know.
Why would it be PR, Will? I'm not saying you're right or wrong. Explain why you're saying PR.
I don't know.
Okay, Will, the smallest side lies opposite the smallest angle. Do you see that in this triangle 1, 35 is the smallest angle, right?
Yes.
So QP lies opposite this 35. See that? PR lies opposite the 45-degree angle. That's the next smallest angle. So you were correct. PR, Will, is the next one because it lies opposite the 45. Now, in this triangle 1, Will, what is the longest side? It has to be QR because it lies opposite the 100-degree angle. This is triangle number 1. Does everyone see this inequality here, guys? Okay. This is the order. QP, PR, QR. Good job, Will. Okay, let's talk triangle 2 for a second. All right. Okay. Nicole, pull me a stick. Martin, in triangle 2, give me the sides in order from least to greatest.
RS.
RS. Why is RS starting off, Martin?
Because it's opposite of 37 degrees.
Yep. What's next?
PR.
PR. Why is that?
Because it's the next longest one.
Yep. Okay,
And
keep
then,
going.
PS.
PS. Okay. Does everyone agree with that? Okay. Ladies and gentlemen, I want you to study these two inequalities. And I want you to now tell me, using these two inequalities, why do we know that PQ has to be less than PS? Look at it. Logically think it through. Why, ladies and gentlemen, does PQ have to be less than PS according to these two inequalities? You can't just compare the two triangles. You have to have a connection that you have to have something that connects the two. Why?
Because PS is greater than PR, but PQ is less than PR.
Okay, so here's say that again, Will.
Good job.
Say that again, Wyatt. Sorry, Wyatt. Okay.
Because PS is greater than PR.
Okay, so here's what Wyatt is saying. PS is greater than PR in this one, right? You guys understand that? Keep going.
And PQ is less than PR.
Here, PQ is less than PR, right? You guys understand that? So you can see if PR is less than PS but greater than QP, what do you know about QP and PS, class? What do we know? PS has to be greater. Do you guys see how we connected that? This side right here, that reflexive side, is what allowed us to compare the two triangles together in inequalities. You guys see that? if we didn't have that side right there, if they were just separated off to the side and they didn't have a reflexive side, we could not compare the two angles in the triangles. You guys understand that? Okay, any questions? Okay, all right. So that's kind of what we've been talking about. That was the first kind of properties in triangles, is we've been talking about angles and side relationships, right? Okay, now another concept that I want to go through is medians, okay? Now that's what your extra credit is going to be on. So what we're going to do now, guys, is we've got a really good problem on medians. And now, when we're talking about medians, Nicole, and I did say on Friday, I wanted you guys to watch the video whether you're doing the extra credit or not. First of all, what is a median? So Nicole, pull me a stick, and this student is going to tell me what a median is. Ellie. Okay, so we probably need to know what a median is, because you will be quizzed and tested over it on quarter 3. So let's take a volunteer. Who could tell me what a median is? Martin.
Isn't it isn't it the middle of all the lines, and then you take that and you draw a line and find the point in the center?
Okay, so here, Martin, you're on the right track. If you do not have Rachel, what do you got?
The line that's next and angles to the opposite.
That's the central.
Very good. Everyone write this down if you don't have it. Rachel, I'm going to have you say that nice and slow, because if you don't have it, you need to know what a median is. So get it in your notes. So if it's not in your notes right now, I want everyone to write the word median. Median of a triangle. Okay? I'm not talking median of a set of numbers, okay? But it kind of is like connected to it a little bit. All right. So Rachel's going to read this off, and you're going to write it down if you do not have a good definition of a median. All right, Rachel, go ahead.
A line that connects an angle to the opposite midpoint.
A line that connects an angle to the opposite midpoint. Very good, Rachel. Does everyone understand that?
Yeah.
That's the definition of a median of a triangle. A line that connects an opposite angle to its opposite midpoint. Okay. So in order to find a median, we need 3 midpoints. You guys understand that? Now, ladies and gentlemen, we're not going to measure this thing, but we're on the coordinate plane. So how do we figure out midpoints on the coordinate plane? What do we do to find midpoints on the coordinate plane? What do we do?
Midpoint formula.
Okay, so we need to know the midpoint formula. What is the midpoint formula? Does anyone have it memorized? It's a very simple formula. So on this one, the midpoint formula, we'll call it the MF. Midpoint formula is very simple.
It's x1 plus x2 over 2.
So x1 plus x2 divided by 2, comma, keep going,
y1 plus y2 divided by 2.
y1 plus y2 divided by 2. Okay, so that's the midpoint formula. So what I need you guys to do is I need you to figure out what the midpoint of these triangles are, okay? So if you want to copy this down, just sketch it really quick. You don't have to do the graph paper. So if you just want to do a quick sketch. So let's get the coordinates here. What are the coordinates of, I'll just start with B. What's the coordinates of B, class?
5, 10.
What is it?
5, 10.
So this is 5, comma 10. See that? What are the coordinates of A? -2, 3.
I was close. I was there.
Okay. What are the coordinates of C? 12, what? 12, -4. So if you just want to do a quick sketch of this, you don't have to do all the numbers and everything. Just do a sketch of this, because that could probably help. So your job, ladies and gentlemen, I want the coordinates of 3 midpoints. I want the coordinates, the midpoint of AB, BC, and CA. And I'm going to have Nicole pull some sticks for that. And I expect you guys to be able to do this. So when you get your stick pulled, I don't want to hear, no. Okay, there's the formula. You can do it. Okay? No. Don't just sit there waiting for someone else to do it, because you're expected to be able to do this. If Your stick gets full. Because this is old news. Midpoint formula is old news, guys. I've been doing it a while. Now don't worry about 15 yet. Okay, we're kind of going to go a different order here. I'm not even really super concerned with all these questions over here. Okay. In fact, so don't worry about the questions as much. I just want to know the coordinates of stuff. So I'm going to erase these, and we're going to kind of do our own questions.
You crossed all the questions. What are we supposed to find?
The median, the coordinates of the median. Okay, excuse me, I said that wrong. The coordinates of the midpoint. Okay, so I just need to know where am I going to graph the midpoint on this side, Sophia? Does that sound good? Where am I going to graph the midpoint here, and where am I going to graph the midpoint here? Okay, got it? Okay, so give me another second here. So the first one I want is AB. Okay, I want to know the coordinates of AB. The midpoint coordinate of AB. All right, so that is going to be found by who, Nicole? All right, Mr. Austin. When you did the math, what did you get the coordinate of a midpoint of AB?
1.5, 6.5.
1.5, so 1.5. Do you guys agree with that? So 1.5, 6.5. So 6.5. So it's going to be about right. Oh, that's bad. So don't round. So 1.5 is right here, right? And then we're going to go all the way up to 6. So you're saying about right here. Is that right? That looks good. Okay, so that's the midpoint of that, right? So how are we going to create a median? Well, what we're going to do is and my line maker tool is just terrible for this. Okay, what we're going to do is we're going to go to its opposite angle, which is C, and we're going to connect that's pretty good actually, for this line maker. We're going to connect that. That's a median. You guys see that? That's a median. Okay. What? Do you agree? Yep. Okay. Now, Nicole, pull another stick. Let's do BC. Who is it? Okay, Nicole. What is the midpoint of BC?
I got 8.5,
8.5 comma what?
4.
1, 2, 3, 4. So right here. Is that right?
Yeah.
You guys agree with that point right there? How many agree with
I thought it was 3.
8.5? 1, 2. So is it 8? So what you're saying, you don't agree with 4?
Yeah,
it's 8.5
Okay. Nicole, will you want to try your math one more time? They're saying it's 8.5 comma 3.
I agree.
You guys are
1, 2, 3. So it's about right here. Is that good, guys? Nicole, do you agree with that?
Yeah.
Okay. So now we're going to go ahead and we are going to make a point, a median from here to here. Okay, Mr. Roden. Will it be flat? Okay. Oh no, it's right at 3. So that actually will be flat, won't it? So it's going to be like this and this. Okay. See, in my line maker tool, it's got to be perfect because remember, guys, we've got to balance these triangles. So we got to make it perfect. Because if it's not perfect, the triangle will not balance on its centroid, right?
Yes.
So, Mr. Roden, we got to be good here. We can't just be willy-nilly in this thing. Okay. Y'all see that? Okay. All right. Now we need to know what the midpoint of segment AC is. Nicole, pull me a stick. Caitlin, what are and your color is going to be rojo, red. Okay, good. What? 5 and negative 1/2. Do you guys agree with Caitlin? Now, here's the deal, guys. What do we know about the three medians? How are they going to relate to each other? I'm not going to graph this yet, but how will I know if I did this correct? Tanner, what will we know? They'll all cross the same point. What do we call it when three lines cross at the same point in a triangle? What's the smarty farty word for that, Xavier? It is, in this case, the centroid, but the general term.
The circumcision.
Because we could have circumcenters.
Is the what, Chris? No. Is the what?
Circumcent. Now listen. Think bigger here. The circumcenter is the point of intersection of the perpendicular bisectors of the triangle, right? The incenter is the point of intersection of the three angle bisectors. That's the incenter. Okay? The centroid is the point of intersection of the three medians. If three lines cross at the same point, those lines are called what, Brady?
Balance point?
In this case, the centroid is the balance point. What I'm getting at is they're called concurrent lines. Do you guys understand that? What does it mean for lines to be concurrent? Martin, what does it mean for lines to be concurrent?
If they're concurrent, doesn't it make the...
Now guys, listen to what I'm saying. If lines are concurrent, they're all going to cross. Three lines are going to cross at the same point. You guys understand that? That doesn't just happen. We could have a line over here, and these lines are not all going to cross right here. It's a very special situation, Sophia, when lines are concurrent. You guys understand that? It doesn't happen very often. It happens with the perpendicular bisectors. It happens with the angle bisectors. And now it just happens with the medians. So let's go ahead and graph this last point, and let's see that they actually are concurrent. Okay, you guys see that? So now let's go ahead and do that. So let's do shapes. We got rojo going here, and then we're going to do this. That's terrible. Yeah, this line, it's terrible. It just drives me crazy. Keeps me up at night. Okay. That's not bad. It's not great.
It's all right. We'll get there. We'll get through it.
Okay, so the problem is, okay, there is some, it's not even human, it's Microsoft. But here we go. You can see that there is not, this should be a little bit more perfect, because if it's not, it would not balance unless it's perfect, right? So you can see that in general, these lines are all crossing right here. And what's the special name for this point here, class?
Centroids.
Centroids. Now, a couple of things I want to discuss with you all. First of all, these are not angle bisectors. You guys see that? Okay? They don't bisect the angles. That's something completely different. Okay? Another thing is, they're not crossing the opposite lines at 90-degree angles. They're not perpendicular. That would be perpendicular bisectors. That would be the circumcenter. If we were talking about angle bisectors, that would be the incenter. You guys understand that? We're not talking about those things. We're talking about the centroid. Now, if you notice, I'm going to go with George on this one. So George, I got a question. Okay, I pulled your imaginary stick, George. So George, I have a question for you. So George, my question is, let's say this. So the centroid, we're going to call this centroid G for George. Now George, is the centroid a midpoint of the segments?
No.
No. Why not, George?
Because the midpoints
are the actual lines themselves, and the centroid.
So let me say this. Let me say this again because I didn't state the question very good. Do these medians bisect each other? That's another way to say it. Do these medians bisect each other, George?
No.
Why? Why do they not bisect each other? So you see the green median. Why does you see the red median? Are those two bisecting each other?
No, I see.
Why not? What does it mean to bisect? George, what does it mean to bisect?
To bisect, it means it'll either be an angle bisector or a line bisector.
Line bisector, not an angle bisector.
For a line bisector, two lines will create two congruent segments.
Very good. So George is saying no. Okay, the green line is not bisecting the red line or vice versa, right? Okay. So why? Because look, guys, if you notice, let's just look at the purple one because I think the purple one's the most obvious. Okay. Do you guys see that this point right here is not a midpoint? It's of this purple segment. Do you guys kind of see it? That this segment right here, this part of the segment, I'll make it green, from here to here, is not the same length from this segment, I'll make it blue, from here to here. Do you guys understand that? Okay, those are not equal to each other, right? So Chris has been dying to talk about this. So Chris, tell me about this concept. It's the 2/3, 1/3 rule. Do you guys understand that? Okay, ladies and gentlemen, very good, Chris. This is, George, you kind of see what we're talking about there? So this, ladies and gentlemen, this is 2/3 of the entire median. Write this down. This is 1/3 of the entire median. Does everyone understand that? Okay. Likewise, this is 1/3 and this is 2/3. Okay? This part of the red one is 2/3 and this is 1/3 of the entire segment. Okay, so I want you guys to see if you guys understand that concept. So I want to come to this. Okay. So I want you to copy this down. Okay. And I actually want you to answer these questions and see if you understand this 2/3, 1/3 rule. So copy this down into your notes. And then I want you to find the measure of FH. Then I want you to find the measure of PF. And then I want you to find the measure of GX. Okay? And it's telling you that point P is a centroid. So this is the centroid. Do you want me to make it bigger?
Yes.
Okay. I will make it bigger. Yep. All right. Here we go. Is that better? Okay, here we go. Someone remind me to stop sharing when we're done. Sound good?
Yes, sir.
Because I will forget. And then it'll be like a 6-hour video.
I would love to watch that. I would watch that.
It will be
Find out
Mr.
what your other classes are learning.
It will be Mr. Roden eating pistachios on his break. It will be, I don't know, be a lot of stuff that's boring, right?
Wait, you don't get perception?
Yes, Chris, and I think they're delicious. No.
Are they salted or non-salted?
Oh, salted, of course.
My mom buys non-salted.
I don't need anything.
I know.
Okay, come on, let's go. Okay, so let's talk FH. That should be a pretty easy concept, correct? All right. So, Nicole, can you pull me a stick? And this student is going to talk about FH for us. All right, Miss Sophia. FH. How long is FH, Sophia?
24.
Okay, you're saying that from this is 24. Why is FH equal to 24, Sophia?
Because HX is equal to 12 and X is the midpoint on it.
How do you know X is the midpoint? Did it ever tell you that it's the midpoint?
Because X is X and G is a median.
Is a median. And what do we know about, by definitions, what are medians?
A line that connects an opposite angle and an opposite midpoint.
Very good. That's the definition that Rachel read, right? Excellent. Okay.
And then so that means that X to F or angle XF will equal 12 and 12 plus 12 is 24.
Okay, very good, Sophia. Excellent work. Does everyone understand that? Excellent job. Okay, so that didn't have to do anything with our 2/3, 1/3 rule, right? That had to do with Rachel's definition of what a median is. A median connects the opposite side, opposite angle to the opposite midpoint. Very good. Excellent. Okay, Nicole, pull me a stick. Okay, Mr. Xavier. Now we want to know the distance of P to F. Xavier, we need to know this distance from here to here. Now this is going to involve our 2/3, 1/3 rule, right? So Xavier, how are we going to do this? Okay, do you guys understand that?
No.
What, Xavier, say that one more time. That's really good. Okay, so this is our 2/3, right, guys? And this is our 1/3, right, Xavier? Okay. Yep. Very good. So if 4 is our 1/3, going to multiply that by 2 to get our 2/3, and so we get that is 8. See that?
Let's go.
Wade, do you have a question?
So when we're doing proofs with this, when we have to prove which side is 1/3, which side's 2/3?
Nope, because by definition, the 2/3 always starts at the vertex of the angle and to the centroid.
Oh.
The 1/3 always goes to the centroid to the midpoint. Sound good?
Oh.
Okay, that's a great question.
You know,
But
Chris, no nasty.
what that tells me is I didn't make that clear enough, right? Does everyone understand why its point is? You always know that the 2/3 starts at the vertex of the angle and to the centroid. The 1/3 always goes from the centroid to the sides. Okay, good question, Wyatt. Well done. Okay, good job, Sophia. Good job, Xavier. Okay, here we go. GX. Now we want to figure out GX. Okay, all right. Who is that going to be, Nicole? All right, Mr. Brady. How do we figure that one out? We want G to X.
So PG is our 2/3.
Okay.
So which is 9. And since it's 2/3, we divide that by 2 to find 1 2/3.
So do you guys understand what Brady's saying here?
Yes.
We know that this is 9, and that's 2/3. So to find this is 1/3. We've got to divide 9 by 2, right, guys? What's 9 divided by 2, Brady?
4.5.
4.5. Now, are we done, Brady?
No, we need to find GX.
So we need to find GX, right? And so how do we do that?
You add 4.5 to 9, which is 13.5.
13.5. And you're
Let's
done.
go.
See that? Well done. You guys see that? Okay. Now, I just want to make this clear, Brady, because I don't think I did, and I want to make sure you guys have this. Because I want to make this clear. Brady automatically said that this 9 is the 2/3. How did you know that 9 is the 2/3, Brady?
Because it's pointing to the vertex.
The vertex to the centroid, right? Okay. Y'all understand that? So remember, guys, that right there is where your triangle balances on itself, right? So pretty interesting. That angle is going to triangle. Okay. Now, here's another thing. Okay, I had this kid says this. And I want you to tell me whether he's correct or not. Okay. In the centroid will be inside on acute triangles on the side, on a side, on right triangles. This guy's name was Smart Art. Man, he was smart. His name was Smart Art. Smart Art. And outside on obtuse triangles. Okay. Now, ladies and gentlemen, Smart, if you remember, and it's been a while since we talked about this, with the circumcenter of a triangle, if the triangle was an acute triangle, the circumcenter happened inside the triangle. Remember that? If the triangle was a right triangle, the circumcenter always happened on the triangle, right? And if the triangle was an obtuse triangle, the circumcenter happened on the outside. And what Smart Art is saying is that same rule will be true with centroids. Did Smart Art get it right?
He's smart, not smart art. His name is Smack Art.
No, it's smart. That's
So he's
art.
not
Art.
smart.
S-M-A-R-T. Smart Art. Guys, you gotta know this. Besides just making fun of his name, can you tell me, is he right or wrong?
Wrong.
Okay, so someone, hold on, I want a stick on this one. Nicole, last stick. Why is Smart Art smart on this problem?
No.
Why? Tell me about Smart Art.
Smart art is smart.
Wrong.
Okay, yeah, I think he is smart, but is he correct about this hypothesis?
This says rank.
No, it's not. No, it's not. It's not.
Okay, all right. So, Wyatt does not sound confident in his answer. So, Sophia, do you find confidence here? Hey, hold on. Let's quiet down so everyone's listening.
Smack Art is not smart because he's incorrect.
Why is he incorrect?
Because you take a right triangle and the thing land inside because it's finding a median to the centroid.
Okay, I have no idea.
Can I draw
There's
my
a lot of-
example?
I don't know that.
Example?
I'm going to George on this one. Hey, George!
Hey, sit down.
Clear it up for us, George.
I'm down
We're not leaving until George clears it up. So pay attention. Side conversation. Keep us here longer. Okay, George, go. Okay, what will the centroid do, guys? What is that point?
It's the center of the balance.
It's the balancing point. Can you take a triangle and have a point outside and balance it on a point outside the triangle? No. It's not gonna happen, right? That's the whole point. Guys, help me there. Can't balance a triangle with a point outside the triangle.
That's exactly what I would do.
George, does that make sense?
I just wondering why I got like funny for that.
Because vertical angles is not necessary to prove these are correct.
Okay.
Does that make sense?
Yeah.
It's not wrong, but it's not necessary.
I know. Roden.
I did get an email. I haven't read it yet.
Hi guys, how you doing?
Hey, why? Drink my double shot.
No.
No.
Oh,
Oh my god.
All right, I'm gonna go back to the back, man. Real quick.
I didn't mean it like that. What the hell? Hi, Miss Gallagher.
Hi, how are
What
you?
are we doing in this
I'm doing
classroom today?
You're doing Apple 24/7?
Me too. No,
Oh,
I'm doing orange.
Horse. Nice.
It's not right. Hold on to it purple.
I don't know. Keep moving.
I'm doing short strips.
Bro, wait, what are we talking about?
I don't know.
I did. No.
My God,
Oh, no.
that'd be our
What is it? Damn. You never see. Have yours.
Yeah.
What?
Number 2, I got an advent calendar of Star Wars socks.
Advent calendar of Star Wars socks.
Yeah, like, quick. This is today's sock.
Oh, nice. Little, what are those? The sand people?
Yeah.
No, those are.
Those are the same.
Oh, I forgot about the.
Kevin, why are you still wearing the band? Oh, sorry guys. Ow!
Here,
No, you didn't.
I know. Wait, who's keeping?
No, that's your own.
All right, ladies and gentlemen, let's take our seats. Here we go. All right. So, a couple of things I want to talk about. Before we get started. Let's take our seats really quick. If I see staff. Okay. All right. Now, hold on for a second, Anna. Okay, a couple things I want to talk about. Number 1 is that on the Santa, I believe there's a Santa graph out there, correct?
Yeah.
That's going to be due tomorrow. Oh, yeah. Santa graph is due tomorrow. If you do not have the Santa graph, you come and see me, okay, and I will give you one, but I'm not going to give it to you now. It is due tomorrow. Did we say it's for a grade, right? Yeah, it's for a grade. So it is for a grade. It's practicing graphing points. Now, if it should look something like a Santa Claus. If it doesn't look like a Santa Claus, then something went wrong. Okay. Now, next thing I want to talk about is your test. We're going to take a test this week, okay? So we're building towards this test. We're going to have a practice test. So make sure that you, we're going to focus on what we do with the practice test. I think we're going to take the test. What's Wednesday look like, Mrs. Baxter? Does that sound good? Let's shoot for Wednesday on the test. So we got to do we got to do the practice test today and tomorrow. We started out already last week, a while back. And then we'll get our practice test ready to go, and we can use that on the test. Remember that Mrs. Gowler and Mrs. Baxter looked at your ADB notes from the test and gave you grades, right, Mrs. Baxter, Mrs. Gowler? Any thoughts on those notes? Some did well and some didn't, right? With that case.
So the ones that decided not to do it or just kind of did one problem, you didn't get a very good grade. And guess what? That was put into the test grade.
Yep.
There were some people.
And then there were some that were beautiful.
Yes. So.
That went above and beyond.
I know for sure, like Dominic's were amazing.
Right. Good job, Dominic. Excellent. So, guys, what I'm noticing is just a few of you are fighting that, but most of you are you're showing your work. You're doing a really good job on notes. So, we're going to have Mrs. Baxter lead us through quick good things. And then after that, we're going to get right to it. Mrs. Galler and I will pass out the practice tests, and then we're going to get right back to it. Okay, so here we go. Let's do it.
And if you, with the Santa thing, nobody turned it into us that I saw.
No,
It's
it's due tomorrow.
It's due tomorrow.
I know, but Justin
Oh,
was
they
asking,
should have.
you might
Yeah.
not,
I did not.
it should be in your stuff.
Yeah,
Not
I did not
in your
collect it.
Mine's in my locker.
Oh, that's not good. Alright, that's a good thing.
So tomorrow we have a choir concert.
Is it like, is it at Doherty's?
No, it's here.
It's here?
Yeah.
Like after school?
I don't know.
Or during
It's all
school?
six.
How do you know?
I don't know.
You're like, I'm just gonna go where I plan. Do you have a solo? I don't know if they have solos.
They do. We have like a lot of solos, but I didn't.
So what's your favorite song that you're singing?
Probably Carol of the Bells.
Carol of the Bells? I remember that one. Awesome. Cassius.
I watched the Broncos game yesterday for free.
You went to the Broncos game yesterday, and they did really good yesterday. I was really sad I didn't put Gordon into my fantasy team. But it's okay. I'm in second place right now. So,
Did
was
you
that
cry?
your first NFL game you've ever been to? Fun, isn't it?
Did you cry?
Yeah,
It was sad.
What was that?
What about the Mary song you laughed?
No.
Mary?
He passed away last week.
That's why they did all that tribute stuff.
Yeah, he passed away last week.
How did he die?
He had a seizure in the shower.
You know what? It wasn't too cold yet. Hey, he's still talking and you guys are being awfully rude. I can stop after Cassius. I have no problem with that.
I only saw like half of their quarter in the red.
Most of the time you're a kid.
I saw one of the players had an ankle injury. I was like, I'm conscious or something, but it's not pretty much I just had to fall in the face.
Did you have good seats or were you nosebleed? I mean, I sat in nosebleed and it was fine, but I also slept through
We're like to the left of the side.
Isaac,
I gotta see that.
you got to see your new house. Oh yeah, I forgot you guys are moving during Christmas break, right? That's awesome. You excited? Are you starting like painting your room and your head out?
No.
No? You gotta start doing that? Hey, what's a good thing?
I saw an actor and a sax in a 2005 Mercedes SO65.
Hey! Rude! Guys,
I saw a 1990 actor and a sax. Oh, 96 actor and a sax.
you have cars. Like cars?
And a 2009 Mercedes SO65.
I'm so glad my husband's not in his car. Like, that makes me happy. Your husband? Why your husband's not in his car?
No, I'm not in the car.
Oh, his husband.
There you are. Yes, you are.
Yes, you are.
I'm not even good.
Anna. I did that last weekend, like 2 weeks ago. Was it not like so much fun? I'm like really good at it. Like really good. Are you good? Can you do 3 at once?
No. How good are you?
I got videos.
Show me.
That's awesome. No, me and my husband just did that like 2 weeks ago with Frozen Hearts. Yeah, it was so much fun. So now my husband is building an Axtroni station in our backyard. Alright, Justin, come on, guys. Sorry.
I saw like
The first one? So Justin watched The Purge. Who else has watched The Purge? Like the TV show? I only like the first one. What did you see the movie? Purge. It's like when they're in the house. And it's like, Alright.
I got a 5 out of 10.
Mr. Roden, do you have anything exciting and good?
My exciting thing this weekend was I was excited to see that the Broncos won. I I'm kind of starting to like the Bronco team more this year. I think they're kind of fighting through and winning games, so it's going to be close. They still have a chance.
What about you, Miss Gallery? Do you have any good exciting news?
I went to Zoo Lights at the Cheyenne Mountain Zoo on Friday night, with my grandkids. It was great fun. It was freezing.
With big cats up? I always go at night because they cats are up. Stories.
They weren't roaring, but they were
I'll get you.
looking around.
Okay,
I already called it. I said just to off one for everybody.
is anyone not here for the practice test?
I don't know if I was or not.
I have one that doesn't have a name that has highlighting on it. It's very beautiful. Did anyone highlight theirs?
Is that Miley's?
Not Miley's. Miley's is here. All right, here's one. Okay, all right.
Miss Gallery, is this yours?
Yeah.
Okay.
Said that was really pretty.